Namaste everyone, welcome to the class. Now let us see the second question first. If the two equal chords of circle intersect within the circle, prove that the segment of one chord is equal to the corresponding segment of other chord. So let us understand what this question is. So in a circle, I have two equal chords. So let us first draw two chords of equal length. So I will draw, say, this chord AB, and here I will draw one chord CD. Let us take this as center of the circle and mark this point, intersection point, as E. So here given, we have given that this AB, chord AB, is equals to chord CD, and we have to prove that segment made by one chord, that is AE, is equals to corresponding segment made by another chord, that is CE. This is first, and second, I have to prove that this DE is equals to BE. So let us prove. Now in this, what I will do, I will first draw a perpendicular from center of the circle and mark point as, say, F and G, or on AB better I will mark F point. So here we will mark 2 points, one is F and other is G. Now as chord AB and chord CD, they are equal in length, then their distance from center will also be equal. So this OF and this OG is going to be equal. Okay, we have to prove that this CE is equals to AE, right? Now as chords are equal, then when we draw perpendicular, then they bisect the chord also. So that is this DG and then this BF is going to be equal. So what I will do, I will do a construction, means I have drawn this perpendicular, and I will join this E and O. So in proof, let us write first construction, what we are doing. Construction. So we are drawing OF perpendicular to AB and OG perpendicular to CD and join O and E, or draw OE. This we have done construction. Now first what I will say, that as AB is equals to CD, AB is equals to CD, this is given. So half of AB will be equals to half of CD. Okay, this is my equation 1. Now OF is perpendicular to AB, therefore this AF is equals to BF is equals to half of AB. This I will consider equation 2. Also OG perpendicular to CD, therefore CG is equals to DG, therefore CG is equals to DG is equals to half of CD. Okay, this is equation 3. Now why we are doing all these things? What we do, we will prove that this triangle OFE and triangle OGE, they are congruent. So once we prove that they are congruent, then this distance GE and then this distance EF is going to be equal. Now CG and AF, they are equal. So from equal lengths, if I subtract this GE and EF, I will get AE equal to CE. Okay, this is all what we try to prove. So here first AF equal to CG we have to prove. So from 1, 2 and 3 I will say that. So therefore from 1, 2 and 3, if we consider all these three statements, what we get? We get this AF is equals to CG. AF is equals to CG. Now I will consider this equation as equation number 4. So this is fourth equation. From 1, 2 and 3. This is not Roman 3. This is 3. Okay. So let us copy this figure from here to somewhere here. Okay, now in triangle OGE or OFE, in triangle OFE and triangle OGE. Now in these two triangles, this angle is 90 degree, angle OFE is equals to angle OGE is equals to 90 degree. Okay, this is our construction. Now OE is equals to OE. This is common hypotenuse, we will say hypotenuse. And third, this OF is equals to OG. Perpendicular drawn from, or I will say that equal chords are equidistant from center. I will say equal chords are equidistant from center. So therefore this triangle OFE is congruent to triangle OGE. Which criteria? This is RHS. It is a right angle triangle, hypotenuse is same and one pair of side is also same. So by RHS these two triangles are congruent. Therefore their corresponding side, that is EF, is going to be equal to GE. We will say that corresponding part of congruent triangle. Now let us consider this as equation number 5. Now subtract equation 5 from equation 4. So I will say subtract equation 5 from equation 4. So therefore fourth equation we have AF equal to AF is equals to CG. So AF minus EF is equals to CG minus GE. So from this diagram we can easily figure out that AF minus EF is equals to AE, and then CG minus GE is equals to CE. So AE equal to CE. Let us consider this as equation 6. So we have proved one part. Now AB is equals to CD. Also AB minus AE is equals to CD minus CE. Here since AB is equals to CD given, so from equal sides I can subtract equal segments. So AB minus AE, this AB minus AE is equals to BE. So BE is equals to DE. So from 6 and 7, so therefore from 6 and 7 we have AE is equals to CE and BE equal to DE, hence proved. So in last problem only we have seen that, and this exercise the problems are going to be little lengthy, right? Okay. This is our second question. Now let us move to third question. If two equal chords of a circle intersect within the circle, prove that the line joining the point of intersection to the center makes equal angle with the chord. If two equal chords of circle intersect within the circle, then prove that the line joining the point of intersection to the center make equal angle with the chord. So again I have a circle. Now in this circle I have two equal chords. So let us draw two chords. So say this is one chord and this is another chord. Again name it as AB, CD. Take the center O. Now what it says that if two equal chords of circle intersect within the circle, so they are intersecting. Let us they are intersecting at point E. Prove that the line joining the point of intersection to the center make equal angle with the chord. So I will join these two lines. Now I have to prove that this EO, okay, makes equal angle with the two chords, that is this angle and this angle is equal. So here again I will say that given chord AB is equals to CD, and to prove we have to prove that angle DEO is congruent or is equal to angle BEO. Okay, so it is same as last problem. Here again we will draw construction. What we do? We will draw a perpendicular on side AB and side CD and prove that these two triangles are congruent, therefore their corresponding angles are equal. Now how we proved that you already know what we have done. So this problem is the same as last problem. Prove that these two triangles are congruent by RHS criteria, and then your angle FEO is equals to angle GEO. Okay, therefore you can say that these two triangles are therefore you will say that angle BEO is equals to angle DEO, hence proved. So simple. So this problem you can try yourself. Now fourth problem, if a line intersected two concentric circle centered with the same center, okay, concentric circles with center O at A, B, C and D, prove that AB equal to CD. So we have to prove that this part AB is equals to this part CD. So what we do here, we will draw a construction. We will draw perpendicular from O to AB. So here you can write given line AD, I will say that line AD intersect two concentric circle at point A, B, C and D. So it is intersecting these two concentric circles at 4 points A, B, C and D. This is given and we have to prove. Now what we have to prove? We have to prove that AB is equals to CD. Now here I will do a construction. I will draw OE perpendicular to AB. So let us draw one segment OE. Let us draw this OE perpendicular to this AB. Now in proof, we know that perpendicular from center bisects the chord. So I will say that as OE perpendicular to AD, chord AD, therefore AE is equals to DE. Okay, reason I can say that perpendicular from center bisects the chord. Perpendicular from center bisects the chord. Okay, so this you can take as equation 1. Now OE is perpendicular to BC also, na? So therefore you can say that BE is equals to CE. This you take equation number 2. Now if we subtract equation 2 from equation 1, so subtract equation 2 from 1, we get AE minus BE is equals to DE minus CE. Now in diagram you can easily work out that this AE minus BE is AB, and then this DE minus this CE is equals to CD. So AB is equals to CD, we have proved. So hence proved. Simple question. Okay. Now let us move to the next question. 3 girls, Reshma, Salma and Mandeep, are playing a game by standing on a circle of radius 5 meter drawn in a park. Reshma throws a ball to Salma, Salma to Mandeep, Mandeep to Reshma. If the distance between Reshma and Salma and between Salma and Mandeep is 6 meter each, what is the distance between Reshma and Mandeep? Okay. So again let us, according to diagram, according to question, let us first draw a circle. Now this circle is of radius 5. Now Reshma throws a ball to Salma. Suppose Reshma is standing here. This is Reshma. Reshma throws a ball to Salma. So let us say here it is Salma. Somewhere here Salma is there, and somewhere here Mandeep is there. So Reshma throws a ball to Salma in this line, and Salma throws a ball to Mandeep in this line. Now they are sitting at a distance of 6 meter. So this is 6 meter, this is 6 meter. Here somewhere there is a center, and this distance between Reshma and Mandeep we have to work out. What is distance RM? So here given, now as I have drawn this diagram, it is given that this RS is equals to MS is equals to 6 meter. Radius of the circle is 5 meter, and we have to find the length of RM, distance between Reshma and Mandeep. Okay, for here I will do a construction. I will draw OR, OS and OM. So let us draw these three segments. First we draw this, then we join this, then we join this, and suppose this point of intersection is N. Okay, any symbol you can take N. So OS and RM intersect at N. OS and RM intersect at N. Now this length, this is our construction. In solution, I will say that this OR is equals to OS is equals to OM is equals to 5, because it is radius. Okay, in bracket I will write radius. Now let us consider this distance ON as x. So therefore this distance SN will become 5 minus x. Okay, so this I will consider equation 1. Okay, now I have joined this OS. Now this chord RS and chord SN, they are equal in length, so they will subtend equal angle at the center. So here I will say that RS as again as RS is equals to SM is equals to 6. So therefore angle ROS is equals to angle MOS. Okay, what is the reason? Equal chords subtend equal angle at center. So equal chord subtend equal angle at the center. Let us consider this as equation number 2. Now if I take triangle and this triangle, this angle is equal to this angle. Okay, so if I take triangle RON and MON, then what I will get? I will get that they are congruent triangles. They are congruent triangles. Therefore this RN and then this MN is going to be equal, and this angle is going to be 90 degree. So here I will just copy this diagram. So where here I will erase this part and this part. Okay, so here now in triangle I will take two triangles. In triangle ORN and triangle OMN. Here we have OR is equals to OM. This is radius. Second, we have ON is equals to ON. This is common. And third, we have angle RON is equals to angle MON. Just now we have proved and considered that as equation 2. So therefore your triangle ORN will be congruent to triangle OMN by side angle side. Therefore I can say that RN is equals to MN and angle ONR is equals to angle ONM, and both are going to be equal to 90 degree because they are linear pair. This is corresponding part. Let us consider this as equation number 3, and reason is corresponding part of congruent triangle, CPCT. Okay, now here, as the problem is too lengthy, okay, I have not used another equation to show that they are linear pair and then their addition is 180 degree and each angle is equal to 90 degree. Okay, each angle is equal, so each angle is equals to 90 degree. Directly you can write Rn is equals to Mn and angle ONR is equals to ONM is equals to 90 degree. So as angle ONR is 90 degree, angle RNS is also going to be 90 degree. So angle ONR is equals to angle ONR, or I will say that angle ONR plus angle SNR. This is 180 degree. Therefore 90 degree plus angle SNR is equals to 180 degree. Therefore angle SNR is 90 degree. Okay, so I have these two triangles as right angle triangle. Now I will take right angle triangle ORN. So I will say that in triangle ORN or ONR, we have angle N is equals to 90 degree. Therefore we use Pythagoras theorem. By Pythagoras theorem, this OR square is equals to ON square plus RN square. OR is of length 5, so this is 5 square is equals to ON we assume as x, so this is x square plus Rn we don't know, so write Rn square. So therefore we get the value of Rn square is equals to 5 square is 25 minus x square. Let us consider this equation as equation number already 3 we have taken, so equation number 4. Similarly, in triangle RNS or triangle SNR, angle N 90 degree. Therefore here also we will apply Pythagoras theorem. So by Pythagoras theorem, RS square, by Pythagoras theorem RS square is equals to Rn square plus Sn square plus Sn square. Now RS, value of RS is 6, so this is 6 square is equals to Rn, we don't know the value of Rn, so this is Rn square plus Sn, the value of Sn is 5 minus x the whole square. So therefore we will say that this 36 is equals to Rn square plus 5 5 is 25 minus 10x plus x square. Okay, therefore from here we get the value of Rn square as this x square will common, this 10x will become minus 10x will become 10x minus x square, and this 25 will go there, so 36 minus 25 is plus 11. Okay, now this is equation number 5. So from equation number 4 and 5, what we can say that, I will say that from 4 and 5, we can equate this Rn square, that is, we will say that this 25 minus x square is equals to 10x minus x square plus 11. Now x square is negative on both the sides, so we will cancel. Therefore, I get the value of 10x is equals to 25 minus 11, which will give me 14. So, therefore, the value of x is 1.4. Now, I got the value of x, therefore, this Rn square, I want the value of Rm. So, for that I will first find Rn. So, therefore, I will say that therefore Rn square is equals to 5 square minus x square. So, this is 5 square minus x square is equals to 25 minus x square is equals to 25 minus the value of x is 1.4. So, 1.4 square. So, this gives 25 minus 1.96. 25 minus 1.96 is equal to 23.10 minus 6 is 4, 9 minus, so 23.04. 23.04. This is Rn square. So, therefore, the value of Rn is equals to square root of 23.04. Now, we have to take the square root of 23.04. The value of x is 1.4, value is 5. So, definitely it is going to be less than 5. So, 4 4 is 16, 4 point something we can say that, 4.8 we can say, 8 8 is 64. So, at the end we have 4. So, like that means we can check 4.8 into 4.8, maybe we will get this 23.04, or let us revise how to find square root using long division method. So, in rough paper or somewhere near to this calculation you can find square root. So, write 23.04. Now, for long division method I will first make pairs. Okay, from left of the decimal I will make pair from the decimal point towards left, and for the decimal points I will make pair towards right. Okay, so this is 23. Now, I will find a square which is close to 23, which is close to 23 means slightly less than 23 or equal to 23, a perfect square. So, 16 is a perfect square which is close to 23 and less than 23. 25 is also there, but 25 is more than this 23. So, we will take 4 and I write 4 here and 4 here. This is the method which we follow. Now, we multiply this 4 and 4, we get 16, we subtract this 16. So, I will get 13 minus 6. So, 7 and 1 minus 1 is 0. Now, I add this 4 to this 4, 4 plus 4 is 8. Now, I will shift this decimal here and bring this 04. So, I always bring in pairs. Now, here I have 704, here I have 8. Now, I will write a number in quotient, the same number I have to write in front of this 8 and I have to multiply, and I have to see that their product is less than or equal to 704 as we do in division. So, let us try with 8 now, because there we seen that 8 8 is 64. Now, 2 2 is 4 and 8 8 is 64, but if I take 2 then it is very small. So, let us check with 8, 8 8 is 64. So, we get 4, 6, 8 8 is 64, 64 plus 6 is 70. So, we are getting 704. So, let us write 8 here and I will get 704. This is completely divisible. So, the value of Rn we get is equals to 4.8. Now, as Rn is 4.8, what I recommend that you show your rough work near to your calculations, do rough work in pencil, so teacher will understand that this is a rough work. So, Rn is 4.8. Now, I have to find Rm. Now, Rm is Rn plus Mn. Now, we have already discussed that when we are proving that two triangles are congruent, there only we have written this Rn and Mn are equal. So Rn and Mn, they are equal. So this is equation number 3. So from equation number 3, I will replace this Mn with Rn. So from equation number 3, I will replace this, I will write Rn plus this Mn is replaced by Rn. I will say from 3. So Rn is what? 4.8. So this is 4.8 plus 4.8. 4.8 plus 4.8, I will get 8, 8, 16, 4, 4, 8, 1, 9. So 9.6. So this is 9.6 meter. So therefore my final answer is, therefore I will say, therefore distance between Reshma and Mandeep is 9.6 meter. Simple. Okay, so this is how we done this problem. Now in this exercise there is one more problem, but I will wind up lecture here, otherwise it will be too long. So thank you for being with me in this lecture. I hope you understand all the problems. And this exercise problems are little lengthy, but no worry, concepts are not that difficult. We have used all theorems or all concepts which we have learned in this chapter or we have learned previously somewhere. So thank you for being with me again. We will meet you in next class.